Hello, and welcome to the second part of my Nextjs ethers tutorial. In the last video, we fetched the same data Aave did for the land to Aave migration from a smart contract, and we rendered it in our user interface. And then we added like a hook to watch for land migrated events, to refetch the data and stuff like that. And this works relatively well, but we have some problems. Like one thing we noticed is that bundle size increases like to 200 kilobytes, which is very heavy for just rendering a number, which is pretty much everything we do right now. And if you see this in the scope like of a bigger application with a lot of users, every of these users will have a connection to our ethers provider, and this will just get expensive. And there might be use cases in which this is useful, like if you use your MetaMask provider to do actual transactions and you really want accurate real-time data. But in our case, it's not really relevant if it's like 20 seconds old or a minute old. We just want it to be somewhat accurate and update in some interval. So what we do now is removing everything we did last time. So remove all the real-timeness we added here, and we utilize Nextjs and Versal to create a little lambda function to give us new data. What we do here is adding migrator data API endpoint, and Nextjs, it's super easy to do this. So you create a folder, then you create a file, you can name it whatever you want. In this case, I created migrator data, .ts, and then you add some export default function, get a request response parameters, and then we set resource status code loose code 200 because it's a tremendous success. And we set some data just to test if it works. So we do some JSON response, JSON stringify hello. And now when you run this, you see yay, we get a hello. Obviously that's not what we want here. So what we want is that, let me see if we can put this below each other. Yes, we can. We want to do exactly the same thing we did here, I think. So I just copy paste this, as I said, put it in a utility function for cleaner code. For the sake of this tutorial, I think it makes more sense to just copy paste it to see where things are coming from. So what we want to return is this migrated land. We have to re-add all these imports. We have to make this async if we are awaiting stuff. Yeah, to import this as well. And now what we should see here is migrated land some number. Yay, it works. So now we have that. All we have to do is integrate it into our application. And for that use case, there's a pretty cool library called SWR, created by the creators of Nextjs, I think, or like somehow related to them. I think this Arunoda guy is involved in it. Check it out on GitHub. It has like beautiful docs, and it's just a very cool library, and it's an encaching layer based on fetch, I think, and it automatically observes stuff on the state management for you, and it automatically does invalidation, so, and refetching. So if you leave a tab and come back, it will refetch the data and stuff like this. So using it is super easy. So you just use it like this, use SWR, and then the first parameter is the URL you want to fetch. How did I call this? My creator data. So my creator data. The second parameter is a fetcher. Let's just define one. So const fetcher equals some URL. And then we just use the browser fetch API. It's automatically polyfilled in Nextjs applications. So it's then we wait for the JSON response. So that's the fetcher. And if we now look at data, yeah, as you can see, like it initializes with undefined, and then it gets the API response here. So we can remove this and instead use data my created land, and here as well. It would be a lot nicer with typing, actually. I should have added the type. Now it's too late for this video tutorial, I guess. But yeah, use a type for these kind of things, because now like these props has to be the same, has to have the same name as the data here, and here like alone for autocomplete. It would have been the better choice. So now when we would build this, you'd see that now the build is around 60 kilobytes or something, because in fact we just removed ethers and stuff like that from the client side, no big number and similar. But we also got one drawback here, and that's we don't listen for events anymore. So data will get stale, like it currently does here. Like we have the exact same problem now here. And what we can do here is add a refetch interval, and it could be something like 2000. This is milliseconds, so that's the difference between gastric props, where revalidate is a seconds number, so it's every 20 seconds. It will build the site new, and in use SWR, it will use milliseconds, so 2000 is the same as 2 in this case. So as we now have this, you see that you don't see the things updating here, and that's because SWR has like built in state management, and data doesn't update, so there's not that many transactions going on here. It will be the same for quite some time. So just to see that it works, we can add a timestamp here in the response. New date, get time. Yeah. And now we should see in the console, like every 2 seconds, this thing popping up because the timestamp changed. So this seems to work, and now we solve this problem of keeping the data fresh. So every 2 seconds we now check if there's fresh data. But we have another problem, and we made it even worse actually over the previous version. So the issue we had, or we didn't had, but we might have had, is that with client side using this ethers client, you have to have some provider which allows like a lot of connections, a lot of requests. There might be multiple listeners listening on events, and this just plots up your quota. So now we use this SWR function, and we refetch data every 2 seconds from our API endpoint. And the API endpoint doesn't implement any caching or something, so it will just always refetch the new data. And if you have like 100 clients or 1,000 clients, and they all always refetch the data, that sums up as well. And it will use the same 2,000 or whatever requests, even if there is no new data, which is kind of bad. But Nextjs, or especially Vercel and their caching layer in their network, allows you to set caching response here, or a cache control header for this API responses. And what you can do here is just res that header, and then set the cache control, and then you can set as max age to some second number. And this stay relevant, while, how can I have that many typos in here? Stay while revalidate property, validate, tells the CDN, actually, that's the CDN from Vercel, to return the stale response while it's revalidating. So if a user requests the page, it will always get the old response, or the available response. And if the available response is outdated, then it's outdated. That's just the case. And the next client or the next request will get more up-to-date data. So what we can see here is that we don't see anything, because I think this doesn't work when testing locally. So because locally we don't have the CDN, this cache control headers, they don't really work. But if you were to deploy this, this would mean that only every 2 seconds we would request a new page if there was a client requesting it. That's basically it. And all the other clients, like if you have 2,000 users and they all request this at the same time, like for the first one it would be updated, and all the other ones would get the up-to-date data. And this would also work like when they frequently fetch the data. That's basically the caching layer in Vercel. And with this, like it was a lot of reduced lines of code actually. What we built here is similar to our real-time event-based layer, but a lot smaller and not based on ethers on the client. I just noticed that we forgot one thing to do here, and like one issue we originally solved in the tutorial was that when you reload this page, it will initialize with 0 and then go to 41.8. And yeah, we don't do this anymore, because data will even be undefined in our case, not 0, but undefined on first load. And what we can do here is just set initial data and stop deconstructing this and just set props here. And it will set the props like the migrated land in initial data. And if we look into this with view page source, we can see the initially rendered data, and it actually contains the number of migrated tokens. So that's it. What we did now is like adding a caching layer in the API layer, and dropping ethers from the client, because for this we just don't need it, and that is the more reasonable approach to target things, I guess. I hope you enjoyed it and learned at least something. See you in the next video. Yeah, have a nice day.